All right, folks, so this is a little tutorial for me to help you out on answering number 1, 2, 3, and 5 on the homework. I am not going to go through number 4 on this video. We will go through that in class, but please know that there will not be anything like this question on the test. As you go into AP Chemistry, you'll have something more like this, but for the test for 9th grade chemistry, that you will not have something like number 4, but you'll certainly have something like number 1, 2, 3, and 5 on your test. So going through that, starting with number 1, describing how I might use a titration to figure out the concentration of potassium hydroxide in a water sample. So basically you're describing a titration. So the way that you would do that is the first thing you would need to do is you would start out, I'm going to put this in first person, I would start with exactly, please notice I'm saying exactly 10 milliliters of KOH. I would then, before I can even start a titration, I need to then add an indicator. The best indicator to use to see where it actually changes would be phenolphthalein. So I'm going to indicate that I'm using phenolphthalein. Spelling on phenolphthalein, not that important at this point. I'd add an indicator. It would turn pink because it is a base. Excuse me, it would turn pink. Then I could take any molarity I choose. I'm going to choose 2 because that's what we've used in the in our lab. So I would take a 2 molar solution of HCl and add it to the KOH drop by drop. Then I would stop when solution, use this up a little bit for you, when the solution turns clear. This is the equivalence point. This shows then the equivalence point. Then describing what the equivalence point, I'm not going to here, describing that the equivalence point is the point. Notice it is also in your reading. The equivalence point, I'll point it out in your reading, the second paragraph from this reading. The equivalence point is the indicator provides a visual sign that the solution has reached the equivalence point, the point at which the moles of base added have neutralized to the moles of acid. So that means that you're equal to the point of your acid and your base. And so then using that equation MAVA is equal to MBVB. Excuse me if you hear my son in the background, he's playing. So I don't know if you can hear him, but I can hear him loud and clear in the other room, having a good time. But so MAVA is equal to MB, and then I would use that. I would calculate the molarity, excuse me, or amount of KOH in water. So that's number 1. Number 2, I'm going to use another piece of paper. Number 2, so number 2 says, what is a lot quicker answer, shorter answer. What is the role of an indicator in a solution? So we talked about that in the equivalence point. So number 2, the role of an indicator, is to show when the acid and base have the same amount of moles, or you can also say the same molarity, or the same concentration. So that's number 2. We scoot this up for number 3. Number 3 is how many milliliters of 0.1 NaOH would be required to neutralize 2 liters of 0.5 molarity of HCl. So this